this session, we discuss classroom workbook. If time permits, we discuss the statistics part, right? So let us start the session with question number 53. Go through classroom workbook. Question number 53. Assume that 45% of the population favors a certain candidate in an election. If a random of size 200 is chosen, then the standard deviation of the sample that favors the candidate is. So they were asking standard deviation, but in this question, the name of the distribution is not specified, right? But based on the data, we can easily guess to which distribution this particular problem belongs, right? So 45% of the population favors a certain candidate. Therefore, in this case, the value of small p equal to 45%. This is nothing but 0.45. So therefore, if p is the probability that the number of candidates favoring a certain candidate is 0.45. So the value of q, this is complement of this. The probability becomes 1 minus of p. So this is 0.55. Now, if a random of size 200 is chosen, that means the value of n is 200. So therefore, here n value is given, p value is given, and we got q value. Therefore, standard deviation. So definitely it belongs to binomial distribution. So in a binomial distribution, the standard deviation is square root of npq. So therefore, this is square root of the value of n is 200, p value is 0.45 into q value is 0.55. Now you simplify this, you get the value as 7.04. So p is given as 45%. That is 0.45. Q is negation of this, 1 minus of this. So this is 0.55. The number of people participating in the election is 200. So standard deviation is square root of NPQ. Now it gives 7.04. Therefore, option D is right answer. Note these points. So it is question number 54. A fair die is rolled 4 times. Find the probability that 6 shows up twice. So whenever the questions are given based on coin and die problems, definitely they will be related to binomial distribution, right? Now die is rolled 4 times. Therefore here n value is nothing but 4. So what basically n represents in the binomial distribution? It represents the number of times an experiment is conducted. What is my experiment? Rolling a die. How many times? It is exactly 4 times. So the value of n is 4. Find the probability that 6 shows up twice. So therefore I need to get 6. But how many times? 2 times. So assume that p is the probability of getting 6 exactly 1 time. So therefore q is nothing but probability of not getting 6. So the probability of getting success, here I feel that getting 6 is success. So not getting 6 is failure. So therefore in this case the value of p is exactly 1 by 6 and q equal to 1 minus p. So therefore this becomes 5 divided by 6. Now let us calculate required probability. So probability of getting 6 2 times. Here x is a random variable which represents how many times the 6 shows up. X is a random variable which represents the number of times 6 shows up. So p of x equal to 2. So the formula is, this is by binomial distribution 4c2 into p square into q square. So 6 has to appear 2 times, non-6 has to appear 2 times. This is the PDF of a binomial distribution, right? So therefore this is 4c2 is 6. The value of p is 1 by 6. 6 into 1 by 6 whole square. Q is 5 by 6 into whole square. Therefore this is nothing but 6 into 1 by 36 into 25 divided by 36. So therefore this is 25 divided by 6 goes 36 in 6 times. So 6 into 36. So this is nothing but 25 divided by, this is 216. So therefore the probability is 25 divided by 216. So option D is right answer. Just we have applied PDF of a binomial distribution. 6 has to appear 2 times, non-6 has to appear 2 times. So this is in the form NCR into p power r into q power n minus r. 6 has to appear 2 times, non-6 has to appear 2 times. So therefore when you simplify this, you get 25 divided by 216. So option D is right answer. The question is the probability of obtaining at least 2 6 in throwing a fair dice 4 times. So this is somehow similar to previous question number 54. The probability of obtaining at least 2 6 in throwing a fair dice 4 times. Previous one is exactly 2 times. Now this is at least 2 times. Okay. So let us see. So die is rolled 4 times. The probability of getting at least 2 times 6. So at least is denoted by greater than or equal. So here x is a random variable which represents the number of times 6 is shown up. So therefore greater than or equal to refers to 2 times at least. So die is thrown 4 times, therefore you may get 6 2 times or 3 times or 4 times. At least 2 means it can be 2 or greater than 2. So 2 times or 3 times or maximum 4 times because the die is rolled exactly 4 times. Therefore in this case this probability becomes 1 or p equal to, this is p of x equal to 2. That means 2, we are getting 6 only 2 times, or is replaced by plus, you may get 6 3 times or you may get 6 4 times. You may get 6 4 times. So basically here x is a random variable which represents the number of times 6 is shown up. So at least 2, that is denoted by greater than or equal. So you may get 2 times or 3 times or 4 times because the die is rolled 4 times only. So here we have 3 quantities. We can do like this also. This is complement of, that is 1 minus of probability of, we are getting 6 0 times or 1 time only, like this. Because when you roll a die, you may get 6 0 times or 1 time or 2 times or 3 times or 4 times. Sum of all probabilities will be equal to 1 because this is a discrete random distribution. So therefore here we have 3 probabilities. P of x equal to 2, P of x equal to 3 and P of x equal to 4. Instead of finding 3 probabilities, I can manage this with 2 probabilities by doing complement of this. So it is 1 minus of P of x equal to 0 plus P of x equal to 1. Now let us see, this is 1 minus of, this is 4c0 into p power 0 into q power 4 plus 4c1 into p power 1 into q power 3. That means we are getting 6 0 times. Non 6 we are getting 4 times. We are getting 6 1 time. Non 6 we are getting 3 times. So here we know the values of p. P is probability of getting 6. It is 1 by 6. Q is the probability of not getting 6. So this is 1 minus of p. It is 5 by 6. Now let us evaluate this. This is 1 minus of 4c naught is 1. So what is Q? 5 by 6. So this is 5 by 6 whole power 4. 4c1 is 4. P value 1 by 6 power 1 into this is 5 by 6 whole cube. So therefore this is 1 minus of 5 power 4 is 25 25 625. 6 power 4 is 1296 plus this is 4 into 5 cube is 125. Of course 4 into 125 is 500. So 500 divided by 6 into 6 cube. Again this is 1296. Therefore this is 1 minus of 1125 divided by 1296. Therefore this is 1296 minus 1125. So this is 171 divided by 1296. Now here let us factorize this. Here sum of digits 1 plus 7 plus 1. This is 9. 9 is divisible by 3. So therefore 3 goes in this. So therefore 3 goes how many times? This is exactly 57 times. Now in this case 3 goes exactly 432 times. Now again this is divisible by 3. Again this is divisible by 3. So we can go for factors. This is 3 19s and this one is 3 144s. Therefore the required probability is 19 divided by 144. So option B is right answer. Note this calculation. Let X be a zero mean unit variance Gaussian random variable. That means Gaussian random variables are nothing but normal random variables. Then E of mod X, that is expectation of mod X. So this is equivalent to n of 0 comma 1. So we have awareness about this. This is a normal distribution with zero mean and unit variance. What it is, the PDF in this case is f of x equal to 1 by square root of 2 pi into e power minus x square by 2. This is the PDF in case of a zero mean and unit variance Gaussian random variable, that is standard normal distribution. 1 by square root of 2 pi into e power minus x square by 2. Of course, limits are ranging from minus infinity to plus infinity. Now we need to find expectation of mod x. Expectation of mod x. So therefore this is mod x function. Now let us see how to evaluate this. Expectation of mod x equal to, since it is a continuous random variable, this is a continuous random variable, the expectations are defined in terms of integrals. It is integral minus infinity to plus infinity, but this is not x, this is mod x. Therefore this is mod x into this f of x dx. So therefore this is integral minus infinity to plus infinity mod x into the function f of x is 1 by square root of 2 pi into e power minus x square by 2 dx. Now here we are integrating this function between minus infinity to plus infinity. Now when you look at this entire function, suppose you call it as g of x. So when you are integrating a function between the limits minus a to plus a, check whether it is even or odd. Now here we have mod x. Mod x is even function. Here even powers of x are there, so it is even. Now here we have a dot, so product of two even functions is even function. Therefore my intention is to say that g of minus x equal to g of x. Therefore the function g is even. So entire function you call it as g of x. G of minus x is g of x. That means the function is even. So when you apply properties of different integrals, this is nothing but expectation of mod x. This becomes 2 times integral 0 to infinity. Now limits are converted to positive side. When you go to positive side limits, mod x becomes x only. Therefore this becomes 2 times integral 0 to infinity x into 1 by square root of 2 pi into, this is again e power minus x square by 2 dx. Now therefore this is nothing but, you cancel this with this, so we get square root of 2 pi by pi into integral 0 to infinity. This is x times e power minus x square by 2 dx. Now the limits are ranging from 0 to infinity. We have an exponential function, so it can be done by using gamma function, because gamma function is this, gamma of n equal to integral 0 to infinity e power minus x into x power n minus 1 dx. This is gamma function definition. Now you can proceed like this. Here in the gamma function we have e power minus variable x only, power is 1. Here we have x square by 2. So to evaluate this integral, you can take x square by 2 equal to some variable p. So therefore 1 by 2 into 2x dx equal to dp. So x is converted to p. But these are limits of x. Let us try to find the limits of p. Here lower limit is 0. 0 square by 2 is 0. Infinity square by 2 is infinity. So the same limits will work even for p also. Therefore this becomes square root of 2 by pi into, this is integral 0 to infinity. This is x dx. 2 will cancel, x dx. So this implies x dx equal to dp. So this x dx is to be replaced by dp. So this is e power minus p. So we know that the value of this integral is 1, because this is nothing but square root of 2 by pi into integral 0 to infinity e power minus p into, we can write it as p power 1 minus 1 dp. So this is square root of 2 pi pi into, this is related to gamma function, but the value of n is 1. So therefore this is gamma of 1. We know that gamma of 1 is 1. Therefore this is nothing but square root of 2 pi. So like this we can find the expectation of a unit variance, a unit mean, unit variance and zero mean Gaussian random variable in terms of gamma function like this. Okay. So proceed this. A fair coin is tossed many times, then find the probability of fourth head occurs exactly at the 10th toss. Options are given. Very interesting question. In this question, they did not mention directly how many times a coin is tossed. A fair coin means on one side you have a tail, on another side you have a head. So a fair coin is tossed many times. Many means it is not clear. So then find the probability of fourth head occurs at the 10th toss. That means indirectly they mentioned that coin is tossed 10 times. So the number of times the coin is tossed is exactly 10. Therefore the value of n is 10. So what you need to find the probability of fourth head occurs at 10th toss. That means in first 9 tosses you must get exactly 3 heads only. Fourth head occurs at the 10th toss. That means in first 9 tosses you must have only 3 heads and rest of the outcomes are tails. Now let us see. In first 9 tosses, you must have 3 heads followed by 6 tails only. So in the 10th toss only you must get 4th head. Now let us see in 9 tosses what is the probability to get 3 heads and 6 tails. You can apply binomial distribution. So the required probability capital P is 9 tosses. Out of 9 you must get 3 heads only. I feel that getting head is success. So 9c3 into small p cube into q power 6 into at the 10th toss. So this is basically the probability of this number gives me probability of getting 3 heads and 6 tails in 9 tosses of a pair coin. This gives me the probability of getting exactly 3 heads and 6 tails in 9 tosses of a fair coin. But the 10th toss I must get head. So the probability of getting head is 1 by 2. Here what is P? P value is probability of getting head. This is 1 by 2. What is Q? Probability of getting tail. This is 1 by 2. So therefore this is 9c3. 9c3 we can write it as 9 factorial into 9 minus 3 factorial. 6 factorial into 3 factorial. Here the value of P is 1 by 2. 1 by 2 whole cube into Q is again 1 by 2. 1 by 2 whole power 6 into 1 by 2 whole power 1 by 2 whole power 1. So therefore this we can write it as 9 factorial is 9 into 8 into 7 into 6 factorial divided by 6 factorial into 3 factorial. This is 1 by 2 cube into 1 by 2 power 6. This is 1 by 2. So this is 1 by 2 power 10. So the 6 factorial will get cancelled. This is what actually 9 into 8. This is 72 into 7 divided by 3 factorial is 6 into 1 by 2 power 10. So 6 will be cancelled 72 12 times. So 12 into 7, 84 into 1 by 2 power 10. This is nothing but 1024. So this value is 0.282. This value is, this is 0.082. This value is 0.082. So therefore, this is very interesting question. Because they did not mention very clearly that how many times coin is tossed. But they were expecting what is the probability of getting a fourth head in the 10th toss. That means coin is tossed 10 times. In the first 9 tosses, you must get exactly 3 heads and rest of the outcomes are tails. So in the first 9 tosses, you must have 3 heads and 6 tails only. So therefore, the required probability is by binomial distribution 9c3 into p cube into q power 6. Where P is probability of getting head 1 by 2. Q is probability of getting tail 1 by 2. So 9c3 into P cube into Q power 6. This gives me the probability of getting 3 heads and 6 tails when a coin is tossed 9 times. And the fourth head occurs in the 10th toss. So the probability of getting single head is 1 by 2. So this is my required probability. So I will get 0.082. So it is option number C. Now let us move to question number 58. A fair coin is tossed independently 4 times. The probability of the event, the number of times heads show up is more than the number of times tails show up. So head count must be greater than tail count. Coin is tossed 4 times. So n value is 4. Number of heads must be greater than number of tails. So the possible cases are 3 heads, 1 tail, or all heads, that is 4 heads, 0 tails. So the probability of the event that the number of heads is greater than number of tails. Coin is tossed exactly 4 times. So head count must be greater than tail count. So there are 2 possible cases. One is 3 heads, 1 tail, or all heads. So when you are finding probability, this R is replaced by the plus symbol. So the required probability P is You must get 3 heads and 1 tail. The probability is 4c3 into 1 by 2 whole cube into 1 by 2 whole power 1 plus all heads. This is 4c4 into 1 by 2 whole power 4 into 1 by 2 whole power 0. Just we are applying PDF of a binomial distribution. Now this is 4c3 is 4. This is 1 by 2 power 4. 4c4 is 1. 1 into 1 by 2 power 4. So this is 4 plus 1. 5 by 2 power 4. This is nothing but 5 by 16. So the answer is option D. Probability that a divisor of 10 power 99 is a multiple of 10 power 96. I read it once again. What is the probability that a divisor of 10 power 99 is a multiple of 10 power 96? Let us see. 10 power 99. So it has certain number of factors. We can easily get the number of factors of 10 power 99, right? So let us see how many factors will be there. The prime factorization of this is 2 power 99 into 5 power 99. So it is in the form P1 power alpha 1 cross P2 power alpha 2. So this is called a prime factorization of 10 power 99. Now P1 is a prime number 2, P2 is a prime number 5. These are natural numbers. So therefore here alpha 1 equal to 99, alpha 2 equal to 99. So the number of factors of 10 power 99 equal to 1 plus alpha 1 into 1 plus alpha 2. So this is 100 into 100. So therefore we get 10,000. So how many factors are there for 10 power 99? 10,000 factors according to prime factorization. So out of the question is, out of these 10,000 factors, how many factors are multiples of 10 power 96? So you cannot write manually all the factors of 10,000, right? Now how to see how many factors of this 10,000 are multiples of 10 power 96? So those many factors divided by 10,000, that gives me my required probability, right? Let me tell you one simple example. So in place of 10 power 99, I will take 100 for example, but I am not saying that 10 power 99 is 100. Now in place of 10 power 96, for example, I will take this is 5. This is 5. So my question is reduced to like this. What is the probability that a divisor of 100 is a multiple of 5? What is the probability that a divisor of 100 is a multiple of 5? Now it is simple for me to list out all factors of 100. So once I list all factors of 100, I can easily check how many factors of 100 are there which are multiples of 5. Now let us see how many factors will be there for 100. The prime factorization of this is 2 square into 5 square. So this is P power alpha 1 into P2 power alpha 2. This is the prime factorization of this. Here the total number of factors of 100 is 1 plus alpha 1 into 1 plus alpha 2. So this is 3 into 3. This is 9. So for 100 how many factors are there? 9 factors. Now let me list out all these factors. The factors of 100 are 1, 2, 4, 5, 10, 20, 25, 50, 100. So all these are factors of 100. We got exactly 9 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you need to select one factor among this. So this is 9C1. The probability is 9C1. You select one out of these 9 factors in 9C1 base. So this is a multiple of 5. This is multiple of 5. This one, and this one. So but these 3 are not multiples of 5. So there are exactly 6 factors of 100 which are multiples of 5. So therefore you take a 1 out of these 6. So therefore the probability is 6 divided by 9. Now it is clear. Since 100 is a simple number, I can able to write all factors of 100. Once I write all factors of 100, I can easily guess how many factors of 100 are there which are multiples of 5. So all tick marks, they are nothing but factors of 100 which are multiples of 5. So how many factors are there? Exactly 6. Therefore you select 1 out of 6. That can be done in 6C1 base divided by 9C1. This is my required probability. So therefore, but this is the answer for this question. That means 10 power 99 I replace with 100. 10 power 96 is replaced with 5. But that is not our question. So to get the clarification, I minimized this problem without changing meaning of the question so that I am getting some clarifications, right? So therefore, let us see what are these ticks. These are factors of 100 which are multiples of 5. Now you can see this 5 can be written as 5 into 1. This 10 can be written as 5 into 2. This 20 is 5 into 4. And this 25 is 5 into 5. So 50 is 5 into 10. And this 100 is 5 into 20. Now look at these things. 1, 2, 4, 5, 10, 20. Actually all these are factors of 20. So they are exactly factors of 20. So this one, this one, this one, this one, this one. How many are there? 6. That's why we got 6 in the numerator part. So to get the answer for this, we need to select one factor from this. Therefore, the required probability becomes like this. P equal to 10,000 C1. This is okay for me. But what is numerator? So I will try to follow this logic. Now let us see. Here 10 power 99, I can write it as 10 power 96 into 10 power 93. Because here 100 is nothing but, 5 into 20. 5 into 20. So how many factors of 20 we got? 1, 2, 4, 5, 10, 20. This 6 I got in the numerator part. This 6 I got in the numerator part. So therefore 20 is replaced by all these 6 factors and that count is required for me to get the required probability. Are you following this? In the similar way, 10 power 99 I can write it as 10 power 96 into 10 cube because they are asking how many factors of 10 power 99 are there which are multiples of 10 power 96. Now let us see. Let us find the total number of factors of 10 cube. So the number of factors of 10 cube. This is nothing but 1 plus 3 into 1 plus 3. So this is 16. Because the prime factorization of 10 cube is 2 power cube into 5 cube. Now therefore here the value of alpha 1 is 3, alpha 2 is 3. So the total number of factors of 10 cube is 16. Therefore I can replace 10 cube by 1. But I am not saying that 10 power 99 is 10 power 96 into 1. But 10 power 96 is a factor of 10 power 99 which is a multiple of 10 power 96. Like this, whatever the logic we followed for this 105, the same logic I am going to apply for this 10 power 99 and 10 power 96. So here 10 power 99 is 10 power 96 into 10 cube. Now let us find the total number of factors of 10 cube. We got 16. Therefore these 16 are nothing but factors of 10 power 99 which are multiples of 10 power 96. These 16 are again factors of 10 power 99 which are multiples of 10 power 96. So you select one among those 16. So the probability is 16 C1 divided by 10,000 C1. This is nothing but 1 by 625. So the required answer is option number A. This is highly worthwhile question. So try to understand this. I think this is very clear. So I have implemented same logic at first for 105 and then applied the same logic for 10 power 99 and 10 power 96.